Howdy, y'all. I'm Darren Nattinger. There's some of you that I don't know, so hopefully I'll meet y'all later today or tonight at the dinner. For those of you that don't know me, I've worked at NI for a really, really long time, longer than the tail on that lizard on that slide. I've worked at NI for 26 years. A lot of that time was in LabVIEW R&D, and most of the content of what you're going to hear today pertains to the work that I used to do in LabVIEW R&D. Today, I am going to teach y'all everything you need to know about VI scripting in LabVIEW. Are you ready? All right, before we get started, I always put all of my presentations up online, and you can access them at dnet.org. There's the QR code for this particular presentation. So the slides are already available at that QR code. You can download them. I guarantee there's going to be some stuff in this slide deck that you're going to want to go back and reference because there are 67 slides, and I'm going to be going through them very quickly. So chances are you're going to have to go back and sort of see what the heck was he talking about. Also, you can see there in the bottom right, I have a download link for Zoomit, the tool that Norm taught me how to use whenever giving presentations, the tool that every single one of you should be using when you give presentations so that I don't have to squint from the back of the room to see what the heck you were trying to show me. Amen. So let's start off with a comic that occupies way too much of my brain space. This is a comic from a webcomic series called XKCD. If you've never checked it out, most of you all probably have because engineers tend to like XKCD. But this one I think about constantly. Specifically because that's my job in LabVIEW R&D for almost 2 decades was thinking about helping y'all make your tasks in LabVIEW, your routine tasks, more efficient. So if you've never seen this before, let me just talk through it real quick. It's basically a chart that tells you, if you've got some routine task that you want to do, how much time can you spend automating that task such that you will end up saving time over the long run. So for example, let's say you've got a routine task that takes you 5 minutes to complete. And let's say you do that task once a day. Then what this chart is telling you that as long as you spend less than 6 days working on automating that task, you will end up saving time over the long run. And the long run with this comic is 5 years. So basically, that's the example for a 5-minute task that you do every day. So one of the reasons I think about this comic a lot, and one of the reasons that I am giving a presentation about scripting today is because there is a word in this comic that is doing a lot of heavy lifting, and that word is the word you. How long can you spend making a routine task more efficient before you are spending more time than you are saving? Who are you? Now, there are a lot of people in this room that are solo LabVIEW developers. We saw that from Jeremy's quiz yesterday. There are a lot of you that work on a team of one. You are the LabVIEW programmer. And for those of you that are in this situation, that comic pertains to you perfectly because you are the one person who's going to be writing the automated tool. You are the one person who's going to be saving time. And so the calculation makes perfect sense for you. Now, what if you are a member of a LabVIEW development team? Many of you in this room work on a team of LabVIEW developers. Well, now it gets a little more attractive because now you're working on automating a task that multiple people will be working on. So now you're saving not just you that time, but you're saving two or more people that time. What if you are me? Well, you are probably not me because I am me. But when I worked in LabVIEW R&D, I was working on tools that saved everybody time. So some of y'all were lucky enough to get a quick drop mouse pad from me the other day. Sorry, I have run out. I don't have any more to give away. But on those quick drop mouse pads, there's a list of the most popular control key shortcuts in quick drop. That list has 8 control key shortcuts. I wrote 7 of them, and I was the tech lead for the 8th one. And I've looked at usage data for LabVIEW. My control key shortcuts have been pressed millions of times since they were added to LabVIEW. So I have saved you guys a lot of time. And in doing that, I have used a lot of scripting to save you guys a lot of time. So that's why we're talking about scripting today. Now, how does the single developer or the developer on a team or me, how do we implement tools that save us time in LabVIEW? There's a few ways. One of those ways is editor accelerators, like quick drop keyboard shortcuts, like I just talked about. Right-click menu plugins for LabVIEW. Now, I've already given a presentation on this topic. It's at the link on the slide, bit.ly/dnat-lvhooks. I've already given a presentation on all the ways you can hook into the LabVIEW editor. Go check that out if you haven't seen it before. What's another way we can use those tools, implement these tools? Maybe we are going to run something across a whole set of code and detect things or fix things. That's like the VI Analyzer can do that. JCrawler can do that from JKI. Well, I've already given a presentation on the VI Analyzer. So that's out there. You can check that out. Another way to implement tools that can save you time is writing a tool once that you're never going to use again. You realize that across your code base, you made a mistake. You need to go run some automated tool to go fix that problem. Well, I haven't written a presentation on that because I don't know what one-off tools you guys are writing. So I can't really write a presentation on that. But I've already got a couple presentations. What the heck am I talking about today? Well, in my presentation on hooking into the LabVIEW editor, one of the ways to hook into the LabVIEW editor, just as an example, is a quick drop keyboard shortcut. And in my other presentation, I have pointed you to the template and said, here's the template, guys. If you want to add a control key shortcut to quick drop, here's where you get the template, and here's what you do. But you know what I haven't talked about? That section in the middle, where you actually write the code that's doing the thing that's saving you time. That's what today's presentation is about. What code goes into that spot and all of the templates for all the editor plugins that say, write your scripting code here. So today, I'm going to be introducing y'all to some building blocks in VI scripting. Building blocks that let you programmatically find things in your code. Building blocks that let you automate changes to your code programmatically. Building blocks that let you add features to the LabVIEW editor, like new right-click menus or new quick drop plugins. Now, how you do that is colloquially called scripting or VI scripting. That's what whenever somebody says that term, they're referring to the code that you write to automate something in LabVIEW, right? Now, as I'm going to illustrate multiple times today, a lot of people say scripting, and it's not technically scripting. And I'm going to kind of get into that as we go on in the presentation. But just, it's a term that people use. You're automating something in LabVIEW. We call that scripting. All right, so how do we get started with VI scripting? Step number one, you have to turn it on. So in your tools options, by default, scripting is turned off. Now, there was a time in the past where this wasn't here. There was a time in the past where only NI did scripting stuff. It was a private feature of LabVIEW. The LabVIEW community wasn't aware of it. Then NI accidentally shipped some VIs that weren't password protected, that had scripting in them. And the LabVIEW community said, hey, what are these things? And started writing tools for it. And the LabVIEW community eventually came up to NI and said, hey, we need this as a feature. And it was added as a feature to LabVIEW. That was quite a while back. So we've had scripting for a while now in LabVIEW. When you go into tools options and you turn it on, like I show in the slide, you get several things. You get a palette. There's a VI scripting palette that gets added to LabVIEW. You get a whole lot of new classes in VI Server that don't show up when you don't have scripting turned on. And you get some useful information that shows up in various parts of the editor, like the context help window. I'm going to talk about that stuff later. So now you've turned it on, what exactly is it? Well, sorry, this is going to be a bit of a downer. VI scripting is just VI Server. You all know what VI Server is? VI scripting is just VI Server. It's just a different color, all right? That's all it is. So here's some VI Server code, right? This is VI Server code that is manipulating the appearance of a front panel object. Hopefully everybody in this room has seen code that looks like this before and understands what's going on here. Here's some more VI Server code. This is code that's opening a reference to a VI and reading a property of a VI. Hopefully that's pretty familiar to everybody. Here's some scripting code. If you've never seen scripting code before, this is what it looks like. Looks pretty familiar, right? You've got a property node, and you're setting a property of something. Only in this case, instead of manipulating the appearance of something on the front panel, we are programmatically manipulating the appearance of something on the block diagram. Specifically, we're setting the subdiagram label text. Now, what's the big difference? It's a different color, right? So now is a good time for me to talk to you guys about the property node color code. Now, throughout the course of this presentation, I'm mainly going to be using the term property node when I really mean property nodes and invoke nodes. I'm just going to say property node to be short. So just remember, most of the stuff I say when I'm referring to property nodes also applies to invoke nodes. So vanilla property nodes. We've all seen these. They're yellow. They're boring. They're not what we're talking about today. We're talking about scripting property nodes. Those are blue. They're fun. Well, there's 2 more colors, you guys. 2 more colors in the property node color code that people from NI don't normally talk about, that I'm going to talk about. And one of them is brown. You guys ever seen a brown property node before? That's a private property node, all right? Now, those can sometimes be fun. I'm not going to lie. Now, there's a 4th color that some people may not have heard of, and that's, I tried to call it pink. I tried to call it red. When I was putting these slides together, my kids said, that's more of a peach color. So I'm like, fine, it's peach. But anyway, these are deprecated properties. So properties that NI implemented at one point and then later on decided we don't want this accessible in the property list. We're going to add a new property or change something. Deprecated properties, if you see one in your code, don't freak out. I am not aware of any deprecated property that NI has ever made stop working. So I would suggest you don't continue using new ones in your new code, but deprecated properties tend to be okay in my experience. In fact, there's a deprecated property in one of our quick drop keyboard shortcuts because it's the only way to do something. So this is the property node color code. Now, this is the point where people from NI who give presentations will typically kind of gloss over that brown one and just move along like nothing was there to see. But I figure it's high time we talk to y'all about some private properties in LabVIEW, and y'all are going to get 2 slides on private properties, okay? Here's the, no, I'm kidding. This is not the first of those 2 slides, all right? I'm going to give you 2 actual slides on private properties, okay? So here we go. There is an INI token you can add to LabVIEW that typically I would have told you, go use Google to try to find that. No, I'm just going to put it in the slide now. So this is an INI token you can add to LabVIEW that will enable private functionality in LabVIEW. Now, one kind of funny thing is that if you don't have this INI token and you open some code with private properties, they actually don't show up as brown. So if you want to see the brown properties, you have to have this INI token. And whenever you enable private functionality in LabVIEW, it adds new classes to VI Server, it adds new properties, it adds new methods, it even adds some events, it adds some hidden right-click menus. Lots of stuff gets turned on with this INI token, all right? None of this is supported by NI. I can't stress this enough. So I currently work in the technical support organization at NI. A couple years ago, one of my colleagues came to me and he said, hey, we got this code from a customer that crashes and he wants some help debugging it. And I said, oh, okay, we have the code? He's like, yeah. I said, okay, what part of the diagram crashes? And he said, the part that calls this method right here. And I said, hey, we can stop right there because we're not going to support the use of this method because this is a private method. And the support ended there, like totally. You guys know me. I like to get y'all unstuck when you get stuck in LabVIEW, unless you're doing private stuff because that's not supported. Usually because these private properties and methods have been implemented for specific internal NI use cases, and they've not been tested outside of those use cases. So they're there. We need them for some internal thing. But when you start playing with it, you may not be doing things in the same way we're doing things for our internal thing, and you're going to crash LabVIEW. So not supported by NI. Not tested. Not documented for general use. However, you might find some useful private stuff in there. Clearly somebody did. Use those private properties and methods at your own risk because, again, not supported by NI. Now, a couple years ago, well, maybe more than a couple at this point, back in the LabVIEW 2019 and 2020 timeframe, LabVIEW R&D worked on basically shoring up a whole bunch of private properties and methods that we knew people were using out in the world to make them more useful for general use, to make them tested, to make them documented. We did a lot of that work back in the 2019, 2020 timeframe. If there's something that's still private present day, there's usually a very good reason that it is still private in LabVIEW at this point. Norm, you can ask me questions later, all right? Okay, so unfortunately, sometimes the private stuff is literally the only way to do things. And I've got a couple of examples here in the slides. One of the examples is kind of a really esoteric case. So you guys know the merge errors function in LabVIEW. Maybe you didn't know that you can right-click on it and there's an option to retain all the errors that were wired into it. Normally that function just outputs the first error that it finds in the list. There's actually a way to have the error cluster retain all the errors that it found, and it uses some special JSON in the source string. It's kind of cool. And you can right-click on the merge errors function to do that. What if you wanted to programmatically modify a merge errors function to make it have this setting? Well, there's no way to do that without a private property. So there's a forums user named Santosh who actually figured out that you have to use this private property to set a flag on the function and then do some other weird stuff to actually enable retain all errors on a merge errors function. That's literally the only way to do it. So that's one of those situations where you don't have another option. One that is a lot more common, though, is the read link or info from file method. This is a very popular method that people use in tools that do programmatic inspection of dependencies of code or programmatic builds, things like that. There's a popular tool on, I guess it's an open source tool called Solution Builder that uses this method under the hood to basically figure out the relationships of things in your LabVIEW code. Also a private method. I have crashed LabVIEW with that method. I've gotten values back from that method that don't make sense. You know why? Because it's a private method. It's not supported for general use. But sometimes, like I said, sometimes those are the only way. All right, that was your 2 slides on private stuff. Let's get back to scripting. So VI scripting is VI server. I'm going to use those 2 terms interchangeably. We can see here on the screen we've got some VI server code. Let's talk through it for a second. Projects. The project is the highest level thing that you can have in LabVIEW. Project has targets in it, like my computer or an RT target or something like that. Each target has something called an application instance. That is basically a memory space where all the VIs in that target can be loaded. Inside the application instances, we have a bunch of VIs. Each VI has properties, a connector pane, a front panel, a block diagram. That's all illustrated in the block diagram code that you see on the slide. We are starting with a project. We're getting the My Computer target. We're getting the application instance of the My Computer target. We're opening a VI reference that's under My Computer, reading a property, getting the con pane, getting stuff on the front panel, getting stuff on the block diagram. That is all VI server code. So when you turn on VI scripting in LabVIEW, all that it's doing is giving you access to the blue stuff. That's all it's doing. As you can see, the code looks the same. It's just blue. So from here on out, if you hear me say VI scripting or VI server, I tend to use them interchangeably. So one quick note I want to mention, property node name format. So maybe you've never looked at this right-click option on property nodes or invoke nodes before, but you can change the name format between no names, short names, and long names. If you set it to no name, you want to watch the world burn. So don't do that. If you set it to short name, that's fine. That's the default. And then you can also set it to long name. Now, long name matches the name that shows up in context help. So sometimes that can be confusing because you see a property node on the block diagram that says terms, like the one on the slide. But if you hover over with context help, it says terminals. That one's pretty straightforward. There's other ones where the short and the long aren't as evenly matched. So just for the purposes of our presentation, I'm going to stick with short names. All of the screenshots that you see are going to be short names on property nodes because that's the default in LabVIEW, even though it doesn't match up the name that you see in that context help window. All right, so when we talk about scripting, remember I said scripting is what gives you access to the blue things. But here's an interesting note. Scripting is just a feature of the LabVIEW editor. What do I mean by that? When you go into Tools Options and you turn on scripting, it's going to do the things that are shown on the slide here. It's going to show you the palette. It's going to give you access to some new properties and methods. But it doesn't change anything about the way that LabVIEW runs. So as an example, let's say we have 2 developers, developer A and developer B. Let's say developer A is Norm. Let's say developer B is Eric. Norm definitely has scripting turned on. Eric probably does not have scripting turned on. So Norm writes some scripting code. And it works on his machine. And he gives it to Eric. Eric runs the scripting code on his machine. It works fine because the execution system of LabVIEW doesn't change depending on the scripting setting. The only difference is if Eric tries to edit that code or add new scripting calls or whatever, he's not going to see the scripting properties in the list because he doesn't have scripting turned on in his LabVIEW. If he goes and turns it on, then he can do the same stuff that Norm can do. So remember, scripting is just an editor feature. It does not change the way that LabVIEW runs. All right, in the world of scripting, the word hierarchy gets thrown around a lot. It can mean one of 2 things. So I want to make sure that I really clarify and drive home the 2 different types of hierarchies we might be talking about when we're working in the world of scripting, and so that you guys can try to keep them straight when you're using that term as well. First, let's talk about the class hierarchy. So everything in scripting in terms of modifying something about a VI inherits from what we call the GObject class. So you can see in the screenshot there. If you look at the menu of all the classes in VI Server, there's a class called GObject. Then you can go under there and start looking at all the subclasses. And GObject is the class that encompasses pretty much everything in a VI, everything in a VI. A panel, all the stuff that could be on the panel. A diagram, all the stuff that could be on a diagram. There are 225 total child classes of GObject. And we're about to go through every single one of them. No, I'm kidding. We are not. let me tell you guys some of the GObject child classes that you should know that are just good general purpose knowledge for when you start wanting to write automated tools for LabVIEW. The panel class. I hope that one's pretty obvious. That is the front panel of your VI. Now you can drop splitters on your front panel, right? Splitters have a class. And once you drop splitters, that creates panes on your front panel. Panes are a VI server class. What can you drop on a pane? You can drop controls, right? We all know what controls are. Booleans, strings, clusters, arrays. You may ask, well, if there's a control class, is there an indicator class? There is not. They all inherit from the control class, and there's a property of a control that tells you whether or not it's an indicator. And then another class that you will run into on the front panel is the decoration class. So when you draw arrows or whatever, or type in a free label, those are all decorations. Those are the most common classes you're going to run into on the front panel. On the block diagram, you've got your diagram itself. You've got wires. There's a wire class. You've got terminals, which is a spot where a wire can start or end. You've got nodes, which is anything on the block diagram that you can wire to. So nodes always have terminals. Structures are a type of node because you can wire to a structure. Functions, so this is going to be the little yellow functions like add or match pattern or whatever. And then growable function, which is a property node or an index array or something like that. Growable function, not a child of function, so watch out for that one. So let me give you guys some examples of some class hierarchies. So let's start with an enum. So starting on the right and going backwards, enum inherits from named numeric, which inherits from numeric, which inherits from control, which inherits from GObject. Okay? Event structure. Remember, we're talking about scripting today, so we're talking about automating changes to your front panel or your block diagram. So an event structure inherits from multi-frame structure, inherits from structure, inherits from node, inherits from GObject. Wire is not very interesting. It inherits directly from GObject. Let's talk about these another way. Let's think of these hierarchies as a taxonomy. So here's the enum from the previous slide and its hierarchy. Here's the event structure from the previous slide and its hierarchy. Here's a red fox, not from the previous slide, and its hierarchy. So think of it exactly the same way, right? Animalia, it's an animal. Chordata, it has a spinal cord, I think. Mammalia, it nurses its young. Carnivore, it eats meat, et cetera. As you keep going in the taxonomy, you get more and more specific as to what that animal, or in this case, that event structure, can do. So the more specific of a class you deal with in scripting, the more properties you get. Here is a property node with the list of properties for the control class. So objects on the front panel. Here's a property node with the list of properties for the numeric class, which is a child class of control, which means it's going to get more properties at the bottom of the list. Here's the list of properties for the enum class, which inherits from numeric, which means it gets more new stuff on the bottom of its list. So the more specific that we go, the more properties that are specific to that thing that we have access to. Now, how do you gain access to those more specific properties, right? Let's think of an example. So we've got a cluster on our front panel that has 3 paths in that cluster, right? And what if we want to manipulate something about those paths that is specific to the path object or the path class, right? We don't want to just change its label. We want to change like the pattern of when you click the browse button or something like that, right? Something specific to the path. Well, first of all, we got to get references to those path controls, right? So here we've got a controls property that will give us references to the controls inside the cluster. But the problem is that those references we get back are of the control class. Well, that is a generic class that does not give us access to things pertaining to paths. And so what we need to do is use the 2 more specific class function. So the code on the right is going to get access to all the controls inside the cluster. It is going to try to turn those control references into path references, because a path is a more specific class of a control. Then assuming an error didn't happen, we are then going to be able to use those path references to modify properties of the path. All right? Everything I just talked about has to do with the VI server class hierarchy. Not to be confused with the owner hierarchy. So when you're talking about scripting, make sure you know when someone says the word hierarchy, are they referring to the class hierarchy? Or are they referring to the owner hierarchy? Here we have a tab control sitting on a front panel that's got a bunch of nested stuff. In terms of the owner hierarchy, the tab owns the page, which owns the cluster, which owns the array, which owns the cluster, which owns the numeric. So this is the owner hierarchy. So objects own other objects. You can place an object inside of another object in LabVIEW, and when you do that, you've established an owner hierarchy. So we're not talking about the class hierarchy anymore. We're talking about the owner hierarchy. Let's take a look at, sorry, one other thing to point out here. Anytime you see red text in these slides, it's probably me trying to call out something that's weird or that you should keep in mind. You would think that if you had a front panel with splitter bars and panes and you had a numeric sitting on one of those panes and you got its owner, you would get the pane. You don't. All controls on the front panel, no matter what pane they're on, their owner is the panel. You actually have to read a separate property to get the pane that owns a control. So that's probably just an artifact of how LabVIEW is set up, and panes were added to LabVIEW, at a later time after the VI server hierarchy got set up, I'm guessing. So watch out for that one. So let's talk about the block diagram. This is a sticking point for some people that are first coming into scripting, because if you look at the example from the previous slide, tab owns the page, which owns the cluster, which owns the whatever. Some people would look at this and say, oh, okay, the while loop owns the case structure, which owns the for loop. Nope, got to stop you right there. The diagram owns the loop, which owns a diagram, which owns a case structure, et cetera. Anytime you see white space on your block diagram, it is a diagram. And in this case, the while loop has a diagram inside of it. The case structure has multiple diagrams inside of it, one for each frame. So keep in mind when you're working with scripting, you've got to watch out for, when you're looking at the owner hierarchy, those diagrams are also in there all the way down. All right, let's talk about tunnels. Tunnels are a little weird in scripting. This case structure has 3 tunnels on it. It's got the 2 integer tunnels, and then it's got the little question mark tunnel as well. In terms of ownership, the case structure owns the tunnels, and then every tunnel has a single outer terminal and then multiple inner terminals, because that tunnel is going to have a terminal for the false case and for the true case. And you may think that I typed those names wrong, because surely the question mark is the selector tunnel, and the regular tunnels are just tunnels, right? Nope, they're wrong. A selector tunnel is a regular tunnel on a case structure, and a question mark tunnel is a regular tunnel. So keep that in mind. Here's a for loop also with a bunch of tunnels. Now, a shift register is not a tunnel, right? Well, in the VI server class hierarchy it is. The shift register inherits from the tunnel. So we've got 5 tunnels on this for loop, and a couple of them are shift registers, and a couple of them are loop tunnels, and then there's the in terminal as well. And remember, tunnels are owned by their structure, and then each tunnel has outer terminals and inner terminals. So I wanted to throw that in there. That's another sticking point when people start writing scripting code and trying to figure out all this tunnel stuff. Got to look out for that. Whoops, it looks like Aaron was taking a picture. Take it quick. Okay. So let's go through some actual scripting code, just some examples, just to acquaint you guys with what it looks like to write scripting code. Let's say we want to write some scripting code that will find all of the while loop subdiagram labels on a block diagram and left justify their text. That is an automated task that we want to do on our VI, so we need to write some scripting code to do that. This is what the scripting code looks like. I'm going to talk through it from the left to the right, okay? The first thing we're going to do is we're going to find all of the while loops on the block diagram. Then for every while loop, we are going to get the diagrams of the while loop, pull off the first one, and get the subdiagram label justification of it. And if we don't get an error, and if it is a justification that's not left, we are going to set it to left. Then outside the for loop, once we're done, if we made any changes to this VI, we are going to save this VI. This is an example of some relatively common scripting code that's changing block diagram aesthetics. In this case, just moving a subdiagram label. Now, why am I reading a diagrams, plural, array of a while loop? While loops don't have diagrams. They have a diagram. Why is that an array? Because timed loops also just have one diagram. Now, timed sequences have multiple diagrams, but timed loops, I guess you could have a timed loop with frames. You're right, but that's a different class of VI server. So a regular while loop can only ever have one diagram, and the reason we've got an array here is because the diagrams property is a property of the structure class in VI server, and some structures have multiple diagrams, like case structures and event structures. The while loop just has one, so we can pull off that one diagram. Another scripting code example. Let's say we need to go through our code, find all the places where we call open, create, replace file, and identify where we have not wired the operation input. So the picture at the bottom of the slide is showing us, okay, we want to find when that terminal is unwired. What does the scripting code look like for this situation? It looks like this. So again, talking from the left to the right. We find all the functions on the block diagram. Then inside the for loop, For every function, we're reading the style property to see if it is an open create replace file function. If it is, we're pulling off terminal index 7 and checking to see if there is a wire connected to that terminal. And if not, this is an open create replace file without that terminal wired. Now, what's up with that style property? Remember how I said earlier that there are 225 classes in the VI server class hierarchy? Unfortunately, not every function gets its own class. Or maybe fortunately, because if it did, then we'd have like 1,000 classes in the VI server class hierarchy. So for a lot of functions, that is the most specific class you're going to get. It's just a function. What is it? I don't know. Read the style property to find out. Scripting code example number 3. I want to start with a blank for loop, and I want to create a numeric shift register that increments the value and initializes with the value of 0. What does the scripting code look like to make that change to a for loop? It looks like this. So starting from the left, we are calling a method to add a shift register to the border of the for loop. Then those next two properties are just reading a bunch of terminals that we're going to need later. Then the method is the connect wire method. It's going to connect the inner side of one shift register to the inner side of the other shift register. Then that wire we just created, we're going to insert an increment function on it. And then on the outside of the loop, we're going to create that 0 constant to initialize the shift register. That is what the scripting code would look like to make that change to the VI. Now notice over here, when we add the shift register, we're specifying a position. And we're specifying a position of 25. What does that 25 mean? Is that 25 pixels below the border of the for loop? Is that 25 pixels down from the origin of the diagram? Is that 25 pixels from whatever structure owns this thing? We're going to talk about positioning of stuff later. So, what are some limitations of scripting? If you see a property or method and it is scripting, in other words, if it's blue, it is probably not writable at runtime. Not always, but sometimes. It is probably not writable in a built exe, and it is almost certainly not readable in a built exe if it has anything to do with the block diagram, because your exe code is not going to have block diagrams, and the runtime engine doesn't have support for most scripting stuff. As a general rule, if something modifies the compiled code on the block diagram, it usually is going to require, probably almost always is going to require that the VI be in edit mode in order to work. What is edit mode? Edit mode is when your VI either has a regular run arrow or a broken run arrow. If your VI is one of those two things, it is in edit mode. You can write scripting code that does all of the things that I just described before. Run mode is if your VI is running, or if it's a sub-VI that's running, or if it's a sub-VI that might start running. Those are the 3 other run arrows that you see there. So some examples of things you can't do when your VI is in run mode. You cannot change the representation of a numeric, because that would change the compiled code. You can't change anything about the connector pane of the VI. You can't change anything non-cosmetic on the block diagram. And even though it has nothing to do with scripting, you can't change the label of a control while your code is running, because that also changes the compiled code. So how do you find out about these limitations? You read the help. So the context help has a nifty little bullet that will tell you if a property or method requires scripting. Now remember, this only applies to the editor. So that only applies to your ability to create that property or select it in the list. Now, in terms of whether or not the code will run in the runtime engine, there is a row in on the detailed help that will tell you, yes, this property or method is available in the runtime engine, or no, or in the case of the one on the slide, yes, this is in the runtime engine, but it's only read-only. So in a built exe, you can read the representation of a front panel numeric control, but you can't actually change it. All right, so what are some common trouble areas with scripting? Application instances. So remember I mentioned before, an application instance is the memory space that your VIs can run in under a certain target. So some app instances that y'all are probably aware of, that y'all have run into when you've worked with LabVIEW. The targets, obviously, my computer. You've worked under my computer. Many of you have written RT code, so you've written VIs that are under an RT target. Another app instance that you probably used but may not have known is an app instance called the main application instance. That's where your VIs are going to run if you don't have a project open. So if you just double click on a VI in Windows Explorer to launch LabVIEW, that VI is going to run in the main application instance. So those are app instances that pretty much everybody in here has run into at some point. Here's some app instances that I've run into. I've run into my computer and RT target. I've run into the main app instance. I've also run into the 30 private app instances that are part of LabVIEW that y'all never see because they're running a bunch of VIs behind the scenes that are part of LabVIEW editor features. So if y'all are starting to write tools that plug into LabVIEW, if y'all are starting to write right-click plugins and quick-drop plugins and whatever other plugins are out there, y'all might need to know about some of these other application instances in LabVIEW. Sometimes your scripting VIs may not be running where you think they're running. So if you write a right-click plugin, for example, that's going to run in this super long named app instance there, because you know Stephen Loftus-Mercer created that one. Quick drop plugins and VI analyzer tests are going to run in a different application instance. And there are two ways to make sure that your VI is running in the right application instance. You can wire that app instance input to open VI reference whenever you need to get a reference to a VI. Or if you've got a project item, you can just read its VI reference property. That'll give you the VI reference in the right app instance. Here's some red text. Beware when your scripting code has an unwired application reference. So if you're writing scripting code and you don't wire anything to that app instance of the OpenVI reference or the app instance of the library open method, you might end up having trouble because you're going to start opening VIs in application instances that you're not supposed to. You're supposed to open it in the one where the owning VI lives. So here's a couple of examples of proper application reference handling and scripting tools. This is a right-click plugin. Some of y'all have probably used it. You can right-click on a scalar constant and turn it into an array. I use that one quite a bit. This is some of the scripting code from that right-click plugin, and you can see that as it's opening a reference to a temporary VI, we're making sure to use the proper application instance for that temporary VI. If that application instance wasn't wired there, our scripting code would probably have problems. Another area where we are doing the proper use of application instances is the Actor Framework, one of the Actor Framework project provider VIs. If y'all don't know what a project provider is, you're really lucky, but I do know what one is, unfortunately. So I'm getting a scowl from Alan right now. So in this case, we are calling a property that is reading a VI reference, but we've already opened the library in the proper application instance, which means that VI will also come back in the proper application instance. Another trouble area in scripting is wiring. Every node has a terminals property. Every constant has a terminal property. Every tunnel has inner and outer terminals. I already talked about that. Front panel control terminals have a property. Every single wire on a block diagram is either going to start or end with one of these terminals that are shown on the screen. But since we're talking about scripting, there are exceptions to every rule. So almost every wire on a block diagram will start and end with one of those terminals. I'll show some exceptions here in a moment. Wiring and scripting can be very easy, or it can be very complicated. I don't know about you guys. I want to do it the easy way. And the easy way is to call the connect wire method. So if you're writing scripting code to automate changes to VIs and it involves doing wiring, just call this method. It doesn't matter which terminal you wire to which input. Things will work just fine either way. This method will just create the wire. You don't have to worry about positioning the wire. You can just create the wire. Here's another alternative. If there's already a wire and you need a thing that's wired to that wire, maybe you can insert something on that wire. Then you don't have to create anything at all. There's an insert node method in scripting that lets you insert things on wires. Now, whenever you're creating wires across boundaries of structures, your first instinct might be that writing scripting code for what I show here on the slide might be a little bit complicated, right? Maybe you have to create the tunnel on the for loop, and maybe you have to create the tunnel on the case structure. You don't. This is what the scripting code looks like. If you've got the terminal on the constant and you've got the terminal on the function, LabVIEW creates those tunnels for you. If you just say wire this thing over here to this nested thing over here, LabVIEW is going to create the tunnels. That's the scripting code. That's all you have to do. Now, how did I know to wire a 1 to the list of terminals for the increment function? It seems like the one on the left should be terminal 0 and the one on the right should be terminal 1, right? Isn't that instinctively what you would assume? Well, your instincts are wrong. Because one of the things you get whenever you turn on scripting in LabVIEW, when you go to Tools Options, like I talked about 300 slides ago, is you get the little indices in the context help window that show you which index in the terminal array different terminals are. So in this case, terminal 0 is actually the output of the function, and terminal 1 is the input. That's how I knew to use a 1 to wire to that. So whenever I work with scripting, whenever I work with wiring, I've always got the context help window open. And I'm always dropping dummy functions on my block diagram and hovering over them to see what their terminal indexes are. Okay, if you've already got a terminal, instead of dropping something and then wiring to it, maybe you can just call the create constant or create controller, create indicator method off of that terminal. If you want your excitement about scripting to die a horrible death, then feel free to use the create described wire method, which is a way that you, as a LabVIEW programmer, can spend hours and hours of agonizing fun determining the exact positions of where you want your wire to go on your block diagram. If you guys hate yourselves, call this method. I don't think y'all hate yourselves. So instead what you do is you call create wire that's just going to go from here to here. You don't care what it does because you're going to call the cleanup wire method after you've created that wire. And LabVIEW is going to take care of making it look pretty good. Definitely better than how you would feel if you tried to position all those joints yourself. Okay, so another trouble area is flat sequences. So I've given y'all tons of rules about scripting so far in this presentation, and flat sequences break all of those rules. For one thing, their class hierarchy. Remember I talked about the class hierarchy? You know, like your red fox, it's a carnivore and a mammal or whatever. So you would expect that a flat sequence would be a GObject, it would be a node because you can wire to it, right? It would be a structure, it would be a multi-frame structure because it's got multiple frames. There's a sequence class, so you would probably expect that the flat sequence would inherit from that sequence class, right? Wrong! The actual class hierarchy of flat sequence is that it just inherits directly from GObject. But it gets worse. The frames of flat sequences, so the block diagram inside of a frame of a flat sequence where you can drop stuff, you would expect that GObject has a child class called abstract diagram. We'll forget about that. Diagram, right? And then you would expect flat sequence frame to inherit from diagram. Wrong. Flat sequence frame doesn't even inherit from GObject. It actually inherits from the level higher than GObject, which is generic. So flat sequences and stack sequences, even though they share a word in their name, have no relationship in scripting. Now you may be wondering, why? Why is that? I actually don't know, but I have a theory. You can do this on a block diagram with a flat sequence, and your VI will not be broken. What? It's a structure, and you can wire from it to itself, and that's not even a channel wire, you guys. That's a normal wire. So I don't know why LabVIEW allows you to do this, but it does, and I'm guessing that's one of the reasons why flat sequences are just weird, and they have their whole own thing in scripting. That's my theory. So best practices when dealing with flat sequences in scripting, be aware of those weird classes that flat sequences have. They've got their own class for their tunnels. So just like the diagram thing, flat sequences have their own tunnels because they do weird stuff. When inspecting your code looking for structures, don't forget about flat sequences, which our good friend Sam Taggart forgot about in one of his recent scripting tools, where he was writing some scripting code that was modifying a property of all the structures on his block diagram. So he wrote code that looks like this, which very clearly modifies properties of all the structures on his block diagram. But structures and flat sequences aren't related. So he forgot to write that extra section of code below there that looks for flat sequences in addition to structures in order to do that thing. So don't worry, Sam, I've made that same mistake before. So that's a big trouble area is flat sequences in scripting. It's been that way ever since they were added to LabVIEW in LabVIEW 7.0, I believe. All right, so let's talk about some miscellaneous gotchas, all right? I sort of referenced this a little bit before with object positioning. When you are positioning things, you might be positioning something relative to another thing, or relative to a subdiagram that owns it, or relative to the top corner of the block diagram. There are some methods in scripting to help you convert coordinates. Like I've got some panel coordinates. How do I convert those to pane coordinates? There's also a really useful way to, whenever you're creating new objects of scripting, to tell LabVIEW to script the new thing in a position relative to an existing thing. Positioning things in scripting could literally take up at least an hour-long presentation. Here's the summary. It kind of sucks. Positioning things in scripting kind of sucks, and you sort of just got to play around with it sometimes to do some experimenting. Or you can drop everything, wire everything, and call block diagram cleanup at the end and tell everybody, this is automatically generated code. Block diagram cleanup should be good enough for you guys in that situation. That's what I like to say. All right, this is a fun one. Sometimes you need a property in scripting and it's just not there. Here's an example. You can set the text justification in a path control. So we can see that I'm using a property to set a path control to have center justified text. What if I want to, in my automated tools, create a path constant with center justified text? Sorry guys, path constant class does not have a text justified property. What's the first thing you might try? You might think, oh, wait a minute, I saw Darren's presentation. He told me about that 2 more specific class function. So why don't I turn my path constant class into a path class and then use its property? Well, that doesn't work because path is not a more specific class of path constant. Paths are things on the front panel. They have nothing to do with constants. So what happens when you run into the situation? There's a property that you need and you don't have, and it's not there. Should you give up? No, you shouldn't give up. You should try to trick LabVIEW. So if you can't find the property that you need, try the typecast function. Believe it or not, this block diagram actually works. We take a path constant, we typecast it to the path class, which has the property we need. We call that property, and that works. Now, it only works sometimes. All right, this is a case that I know works, and I've used it before. When it doesn't work, you might crash LabVIEW, all right? But when it does work, you feel like a real hacker, and it's awesome, all right? Okay, another gotcha. There is a function in LabVIEW called OpenVIObjectReference. It is in the scripting palette, and you should never, ever use it for two main reasons. Number one, it does not look inside of nested things, and number two, it's one of the few memory leaks I know about in scripting where if you call this function on the same thing, it'll give you a new reference each time. So I've seen people have memory leaks where they call this function in a loop, and it's giving them the same reference, the same thing, but it's giving you different references every time. Don't use it. Instead, use traverse for G-objects and tref find object by label, which I will talk about a little bit more in the remaining 3 minutes that I have. All right, so another thing in scripting is doing bumps. Whenever you make a change to a VI in scripting, it should act just like making the change in the editor. So you right-click on something and change a property versus call the scripting code that changes that property should behave the same. Doesn't always behave the same. A lot of times when it doesn't behave the same, you might have a broken VI that looks runnable or a runnable VI that looks broken. You might have redraw issues. In those situations, you might need to do what I call bumping the code. And here's some examples of how you might bump the code. You might set an object to its same position as it already is. You might set an object's label to the same label it already is. You might call the compile method on the VI, which you shouldn't have to do because VIs always compile when you make edits. But there's sometimes where you need to bump the code to make your scripting change stick. So watch out for that. All right, some best practices and tips. Remember my comic? The first question you should ask yourself when you encounter a repetitive, tedious task in scripting is, can I solve this by writing some scripting code? Now, this happened on the LabVIEW Discord a while back, where somebody was told, hey, you need to turn off debugging on all your VIs. And the guy goes, okay, well, gosh, that took me about an hour to open all those VIs and change that property. And I posted that reply there, which some people said I kind of looked like a jerk when I did. I wasn't intending to be a jerk. I was just pointing out you could have saved some time by just writing some code that looks like this. So that definitely would have saved him an hour because it took me like 30 seconds to write that. Also, I'm breaking one of my rules in this code, which is I'm not wiring the app reference in the OpenVI reference. It's probably OK in this case because you're just running a tool to just do a bulk operation on a bunch of VIs on disk. Probably OK. Also, why is that 2 there? In scripting code, you should always wire a to option to the OpenVI reference function. If you're familiar with that option, it makes it so that template VIs are opened for editing. Otherwise, OpenVI reference is going to spawn a new instance of a template VI, which you almost never want when you're writing scripting code. OK, mimic the editor whenever possible. Scripting operations kind of feel like the same thing you do in the editor. If you create a new function, that's the new VI object. There's a method to connect 2 wires. There is a replace method, which does the same thing as right-click replace. You can change the label of a control with the label text property. If you right-click and remove a structure, there's a method that does that. If you want to grow a build array, there's a method that does that. So everything you can do in the editor, you should be able to do in scripting as well. If you can't find the right property, a lot of times it ends up being a method. There's not really any rhyme or reason for why some things end up being properties and some things being methods, so watch out for that. All right, Control-Shift-B. If you've never used this tool before, it launches the class browser. Some of y'all have your laptops open right now. If you're in LabVIEW, you can press Control-Shift-B and see the class browser. When you press that, the first thing you want to do is click the search button, which brings up a search dialog. Change the search dialog to search for it through everything. Type the thing you want to search for. And after you double-click on the result you want, it goes back to the class browser. And this is the coolest part. You can drag things from the class browser onto your block diagram. So if you've never used the class browser, it's your friend. You know what else is your friend? Control-space, Control-B. Let's say you have a class specifier constant. You want to change it to the timed loop class because you want to do some timed loop scripting. So what do? You drop a class specifier constant, you right-click on it, and now you're in the right-click menu hell, and you're like, dude, LabVIEW, come on. Why do I have to do this every single time? So instead, use quick drop. Select the class specifier constant, type in the class name, timed loop, press Control-B. It will automatically change the name. This does not have autocomplete. I would like for it to have autocomplete someday. Right now, you kind of have to know the exact name that you want to type in. Okay, undo transactions. Remember, this whole time we've talked about how you write your scripting code that goes into your plugins. If you are writing scripting code that's part of an editor feature, you probably want people to be able to undo that thing, right? You want to be able to undo a right-click option. You want to undo a quick drop operation. Some features of LabVIEW automatically handle the undo transactions. Sometimes you have to write the scripting code yourself, but when you have to write it yourself, it's going to look like what you see on the slide there. Beginning undo transaction and ending an undo transaction. Use templates as much as you possibly can. The easiest way to script code is to not script code. Use templates that contain your boilerplate code. Don't make your templates part of libraries. I've given that advice a million times. Your templates should be sitting off in an auto-populating folder somewhere. Drop a sub-VI, create wires to it, and then inline it. Now, I'm not talking about the inline setting on the execution page. I'm talking about this kind of inlining, where we've got scripting code where on the left side of this diagram, I'm creating controls and indicators for the sub-VI terminals. On the right side of the diagram, I'm calling a scripting method called inline, which is going to explode the contents of the sub-VI onto its owning diagram. So see the code on the right? That would be kind of a pain to script the for loop and the select and all that stuff. But if I can have all that stuff sitting in a sub-VI, I can drop the sub-VI, wire to its inputs and outputs, and then inline that sub-VI, and it'll explode it, and you'll see all the contents. Much easier way to do a lot of scripting than having to create every single object yourself. Templatize as much as you possibly can. The request deallocation function is always going to be in any scripting code that calls the data type property, otherwise you might crash LabVIEW. All right, traverse for GObjects and tref find object by label are two of the most interesting VIs that are part of LabVIEW. They are ways to find things in VIs when you're doing code inspection and template development. Traverse for GObjects is in the scripting palette. tref find object by label is a hidden gem that's in LabVIEW. How do you identify things? Well, you can identify them by something called a UID, which is an internal property of things. I tend to not do that because I can't actually see the UID of things on a block diagram, but what I can see is labels. So whenever I'm working with scripting, working with templates, I will use a label and find that object with tref find object by label. Which references should you close? I've talked about this in other presentations. Close all the references that you see on the slide here. Don't worry about closing GObject references, which is what I've been talking about this whole time, except for GObject references that are called by OpenVIObjectReference, which, if you recall correctly, there was a slide a few minutes ago that told you to never use that function. Scripting is fast. The slowest part of scripting is when you have gigantic diagrams. The slowest part of scripting is when you're opening VI references and saving VIs. There's something in scripting called type propagation, or I'm sorry, something in LabVIEW called type propagation, where every time you make a change on a block diagram, data types propagate across the whole diagram. You can try to suppress it. There's a private property called suppress type prop. Use it at your own risk. I have seen this thing screw up some scripting tools in the past. Also, don't bother parallelizing your scripting code. Every single scripting property and method runs in the UI thread. If you've got parallel scripting code, it's not going to run in parallel, so don't even bother. Where do we go from here? So I know I'm out of time. I'm wrapping up, I promise. I told you guys I would teach you everything you need to know about scripting in LabVIEW. I may have oversold a little bit, all right? If the tail of the lizard is everything you need to know about LabVIEW, the red part is what I've talked about today. So there are still parts of scripting that I didn't cover today. My favorite scripting resource is existing code. So if you can find code like a quick drop plugin that does something similar to what you want to do, go check that out because you can open it up and take a look. There are shipping examples of scripting. There's a tutorial on ni.com. Watch out, the tutorial has OpenVI reference or OpenVI object reference functions. Ignore those. The best scripting resource is the LabVIEW Discord. So the LabVIEW Discord has a scripting channel. I participate on there. Lots of the people in this room participate on there. When you join the scripting channel, or when you join the LabVIEW Discord and join the scripting channel, you'll get that channel that has a place where you can ask scripting questions. I'm not even the one that answers all of them. There's plenty of other people that answer questions there as well. So we're going to end. Sorry, I went over for a few minutes. We're going to end with the same XKCD comic that we started with. So I'm going to tell a little bit, a quick story, less than 1 minute, about a you, in this case, which was a single team LabVIEW developer. So a solo LabVIEW developer, a beloved member of the LabVIEW community, Steve the Butcher, who's in the room with us today. So Steve posted on the LabVIEW scripting Discord, hey guys, you know what annoys me? When I drop a Boolean and it highlights the label text and I type in label text, but I also want that text to be the Boolean text, and I want to hide the label. I have to do that manually every single time. And he asked, is there a way to fix that? And I was like, well, I don't know of there's not a built-in way to do that in LabVIEW, but you could write a right-click plugin. So he said, OK, so I pointed him to where you learn about how to write right-click plugins, right? So this is a thing that probably would save him about 5 seconds. This is a thing that he probably does at least once a day. So as long as he spent less than 2 hours on this task, he's going to end up saving time in the long run, right? So from the time that I pointed him to the video on how to make right-click plugins to the time that he posted, hey guys, I figured it out. I looked at the timestamps on Discord, it was 33 minutes. So over the course of 5 years, Steve is going to save an hour and a half from this work, roughly, right? But that's not really the whole story. Another big part of this was how much fun it is to write scripting code, all right? He's saving an hour and a half, but he's having fun while he's doing it. And every single time he does that right click that he wrote, it's going to make him smile. That's the best part about scripting. Sure, it's a time saver, but also ask any of us that write a lot of scripting code. It is a whole lot of fun. Sorry I went over on the time. That's it. Thanks, everybody.